Our next installment here in our final exam test prep is on not graphing quadratics, but it is on projectile motion. If you want to flip to the projectile motion part of your packet, this is not one from your packet. This is just something to help you through it. So the first thing we got to do is we got to understand what each variable means. Okay, so when I see h parentheses, oh boy, got some of my wires caught up here. When I see h parentheses t, that equals height at a given time. When I see 1/2 a, that just, or sorry, 1/2 a, to us that will always be -16. That is acceleration due to gravity. Okay, we do live on planet Earth. That's what happens. Things are thrown up in the air. T will be time whenever we're doing projectile motion. That's what it's always going to be for us. V with the subscript O on it. So V in this little 0 here, we call that V naught. That means initial velocity. Okay, I'm going to draw my little thing there, and then H with the little 0 down there, that means H naught, and that is our initial height. Okay, draw my zeros in there so it looks perfect. 0, 0. Okay, so that's what those stand for. So initial velocity means starting velocity, how fast it was going at the start, and then initial height as well. Okay, so just by looking at the equation that it's shown, so this equation shown right here, I should be able to look at this equation and answer questions just by looking at it. So what is the initial velocity of the rocket? So I got to go back and look at my equation. This is -16 t squared plus 224t. That's in my v naught spot. So what's the initial velocity of the rocket? The initial velocity is 224. Okay. How did I get that? I got it from, I know that v naught stands for initial velocity. And h naught, if you look, it doesn't have a t behind it, and this definitely has a t behind it. B, what is the height of the rocket 5 seconds after it was launched? Okay, so it says the height in feet 8, h t, a firework, t seconds after launch is given by the function. So what I got to do is I have to rewrite the function, -16, and then instead of writing t, I'm going to write 5. I'm going to write 5 there. Okay, so -16t squared plus 224t, which is 5. That's how many seconds. Okay, and we're going to have this little 2 here for squared. Okay, so I type all that in my calculator. Let me press pause so I can type it in. When I plug that into my calculator, I get 720. So that equals 720. So that's how high it was after it was launched. 720 what? 720 feet. Okay. Now it says, what is the max height of the rocket? Anytime you see max height, your spidey sense should be tingling. You should say, look for the vertex. Okay, how do you do that? In order to look for the vertex, you have to find the axis of symmetry. Okay, if I go back and look here, axis of symmetry is negative b divided by 2 times a. So I've got to do negative b divided by 2 times a. So negative b, so that's parentheses, negative 224 divided by, I'm just going to do the slash for divided by 2 times -16. Type that in my calculator real quick. 224, you should be doing this too. It shouldn't just be me. You should be totally doing this as well. That gets me 7. What is 7? Is 7 the max height? No. 7 is my x value. That's my axis symmetry. So now I got to take 7 and plug it in for t. So I go back to my original equation, -16 parentheses 7 squared plus 224 parentheses 7. Now I've got to go back and type in my squared because I don't have a squared thing on my keyboard. It's not a great math program. I typed that in my calculator. Go ahead, try to beat me, people. I dare you. Type it in your calculator. What did you get? Did you really? Okay, that's good. I got 784. 784 is the max height of the rocket. So I'm going to write it really 7, 8, 4 feet. Okay, so that's the max height. Now it says if the firework is shot inside of a dome that is 700 feet tall, 700 feet tall. Sorry about that. A lot of people running through the hallway. So 784 feet is my max height. Now, do you have to think in real life there? If the firework is shot inside of a dome that is 700 feet tall, will the firework hit the ceiling? Well, if it goes up, if the dome is here and it's 700 feet to the top, and our max height's 784, is that higher or lower? Correct, it is higher. It's about right there. It would blast through the ceiling. So will the firework hit the ceiling? You would say yes, with a tremendous explosion. Explosion's hard to spell. There we go. All right. This should help you with projectile motion. You should work on your study guide accordingly to this.